conservation of angular momentum. The angular momentum of a system of particle above any point is given as LO is equal to sum of angular momenta of all particles with respect to that reference point. The rate of change of this angular momentum of the system is equal to the net torque exerted on the system, that is due to the external forces only. And if the net torque acting on the system is equal to 0, we have dl by dt about this reference point will be equal to 0. This gives us a constant angular momentum of the system with respect to the given reference point. This states that the angular momentum of a system remains conserved when the net torque acting on it is 0. Needless to mention, with respect to a given reference point. This is what we call the principle of conservation of angular momentum of a system of particle. It may be having one particle or it may contain many particles. Let us take some examples to understand this theorem. Let us take an example for that. Say the sun planet system in the sun planet system, let the planet be here and it moves with velocity v with respect to the sun. It has position vector r and the planet is pulled by the gravity of the sun, which passes through the sun itself. Since the torque acting on the planet, this is the sun, this is the planet P, is tau is equal to about S is equal to R cross F G. This is the R vector, this is the force vector. What is the angle between these two? 180 degree. R F J sine 180 degree. The magnitude of the torque is equal to 0. Since the system experiences no net torque, the angular momentum of the planet with respect to the sun remains conserved. You can conserve the linear momentum of the entire planet plus sun, because the net force acting on the system is 0, because the sun is pulling the planet with a force Fg and sun is also being pulled by the planet with a force of same magnitude in opposite direction. So, net force acting on the sun planet system, sun plus planet system, the net momentum remains conserved, because the net force acting is equal to Fj plus minus Fg equal to 0. So, conservation of linear momentum can be applied if you take the entire as a system, but if you take this as a system, net force acting on the planet is not equal to 0 on the planet. For the entire system, the momentum is conserved, but however, for the planet only, net force acting is not equal to 0. Therefore, momentum of the planet is not constant. It keeps on changing its velocity, its both direction and magnitude from time to time. So, on sun planet system, you can conserve the linear momentum, you can also conserve the angular momentum. However, if you take the planet only, you cannot conserve the momentum, but due to the gravitational force as a conservative force, you can conserve the energy. Energy is equal to kinetic energy plus potential energy, total mechanical energy can be conserved. So, energy conservation holds good for the entire system. For the planet, the linear momentum conservation also holds good for the entire system, sun plus planet system. However, for the planet, you cannot conserve it. But conservation of angular momentum will hold good for the sun plus planet case, or on the planet also you can conserve the angular momentum, because these forces will pass through the center of mass. Center of mass is lying very close to the center of mass of the sun, because the sun is very huge compared to the planet. So, this is a little bit subtle matter to consider the conservation laws, conservation of mechanical energy, conservation of angular momentum and conservation of linear momentum for sun planet case.